Today in lab, we're going to be discussing the accuracy of glassware. So to measure different liquids in lab, we have quite a few different apparatus. Here we have a beaker. Here we have a volumetric pipette. This is a burette, and we have a graduated cylinder. And each have their own applicabilities when it comes to measuring volumes in liquids. So which one do you decide to use, and which one happens to be the most accurate? Well, let's dig into it. With Amy. So the first thing we're going to do is work with our burette. We're going to determine how accurate it is. To do so, we're going to fill it with deionized water. Now, the bottom of the burette isn't typically measured as a volume, so we need to make sure that it's filled with water in order to accurately determine how accurate the burette is. So we're going to fill it with some water, and this is deionized water. Once we have some water in there, we'll let a bit drain out to make sure that the empty volume at the bottom of the tip is filled with water. Now that that's full, we can go ahead and fill the burette to the top. Notice that the burette at the bottom starts at 50 mils and goes all the way down to 0. So this is typically read in a reverse way, meaning it starts at 0, and as you expel liquid from the burette, you can count how many milliliters you've expelled. So now that Amy has filled this almost to the 0 mark, as long as you annotate where you started, you can calculate the difference of how much you expelled. From the bottom of the meniscus, this burette will be read as 0.71 milliliters, which Amy will document here on the board. Alright. Next, we're going to take a 50 milliliter beaker and weigh it. The weight of this 50 ml beaker is 28.972 grams. From here, we would take this dry pre-weighed beaker, place it underneath the burette to collect the water that we expel from it. We will now deliver 20 mils of water to the pre-weighed beaker. Once 20 mils have been released from the burette into the beaker, you can twist the stopcock at the bottom of the burette to stop the flow. Then record your final volume reading shown on the burette. The volume indicated by this burette is now 20.70, which Amy will record on the board. Now, to calculate the accuracy of the burette, we will weigh the water in the beaker to determine how much water is actually in the beaker. The mass of the water in the beaker is 48.670 grams. This is the first trial of the experiment. We will do this same exact experiment for trials 1 and trials 2 and trials 3. The temperature of this room should be documented as 23 degrees Celsius. There is an attached appendix in the lab manual to describe the density of water at this temperature. This can be used to calculate the mass of water. And from there you can calculate the accuracy of the burette. For part B of the experiment, we'll be determining the accuracy of a graduated cylinder. The initial mass of our 50 ml beaker that we're going to use to dispense water into is 28.979 grams. The temperature of water to be used is 23 degrees Celsius, which is the room temperature of this lab. In the appendix, you will find the density of water listed at this temperature 23 degrees Celsius. When we find the mass of the water delivered to the beaker, you can then calculate the volume to determine the accuracy of the graduated cylinder. Let's get started. Here we have a 100 ml graduated cylinder. Into this 100 ml graduated cylinder, we will deliver 20 ml of water from a beaker. We'll get as close as we can to the 20 ml mark, and then use a pipette to bring us as closely as possible to the 20 milliliter. As seen, measured from the bottom of the meniscus, we have 20 ml of water in the 100 milliliter graduated cylinder. We will take these 20 ml of water and put them into the 50 ml dry pre-weighed beaker. We will then take this 50 milliliter beaker with the water in hand and find its mass. The mass of this should be recorded as 48.526 grams. We will repeat this for trials 2 and trial 3. For part C of the experiment, we'll be determining the accuracy of a 50 ml beaker. The temperature for the water will be the same. Temperature will be room temperature at 23 degrees Celsius. Using this temperature, you can evaluate the density of water and from there find the volume of the water and determine the accuracy of the 50 ml beaker. Let's begin. First, we'll take the mass of the beaker. This beaker is empty and dry. It's 28.972 grams. From here, we will place 20 ml into the 50 ml beaker, coming as close to the 20 ml mark as possible. Remember, always measure from the bottom of the meniscus. Once you have the 20 ml of DI water in the 50 ml beaker, take its mass again. The mass of the 50 ml beaker with the water is 48.962 grams. We will repeat these measurements for trial 1, 2, and 3 for a total of 3 trials. For part D, the final part of this experiment, we'll be determining the accuracy of a volumetric pipette. To do so, we'll be using the same 50 ml beaker, which is dry and empty, and finding the mass. Here the mass of the 50 ml beaker is 28.969 grams. We have this recorded. We'll be using the same temperature water, 23 degrees Celsius, which is the room temperature here in the lab. Same measurements for density. We'll find the mass, and then you can calculate the volume. Here we go. This is a volumetric pipette. Alright, in order to draw water into the volumetric pipette, you simply turn the knob at the top with the tip of the pipette in the water. We draw water into the pipette, through the bulb, into the fill line. Now that we have the water at the fill line, we will dispense the water into this dry 50 ml beaker. Now that all the water is in the beaker, we can take the beaker with the water in it, and again, find its mass. The mass of this beaker with the water is 48.906 grams. We will repeat this for trial 2 and trial 3 for a total of 3 trials.